Hello guys, I'll be teaching maths, Form 4, Chapter 7, Graph of Motion by SPM Maths Booster. So let me introduce you. There's two types of graphs. The first one is distance time graph, and the second one is speed time graph. Let's get through with the distance time graph first, and then later speed time graph. So there's two examples of different time graph here. There's three. As you can see, here's the sun. You saw that the distance is here. I mean, at the y-axis, is the sun. This is on the sun from above. Normally, you saw this three type of the question. The gradient for the gradient for O to H, the gradient is positive, and for H to I, the gradient is 0, and also called stationary, which means that the distance still remains the same. You can see the distance didn't move up, so it's stopped at here. And then to I to J, the gradient is negative. Going up, it's positive. A remaining straight line, no gradient, and down is negative. All these things is all same. O to X positive, also going up. And then X to Y, it's remaining the same, which is 0 or all secondary. One is X goes up, it's positive. And for us, it's also same. O to A is positive gradient, A to B is negative gradient. So what do you? The question asks you to find speed for distance time graph. And for speed formula is distance divided by time. And the other one is saying just add a total in, like total speed equals to total distance divided by total time. And let's get through the example one. The diagram above shows the distance time graph of a moving particle for 4 seconds. Find question A, the distance traveled by the particle from the time 2 seconds to 4 seconds. B, the speed of the particle last 2 seconds. So question A is asking for distance travel from 2 seconds to 4 seconds. 2 seconds, 4 seconds. So the question asking this distance. So simply we just take 50 meters minus 5 meters is equals to 10 meters. 50 m minus 5 m equals to 10 m. And m as meters of time short. And another is finding the speed for the last 2 seconds. Speed for the last 2 seconds. So you still remember the speed formula. Speed is equal to distance divided by time. So for distance in the last 2 seconds is 50 minus 5 divided by time, 4 minus 2. We're going to add it here. 50 minus 5, I will get n. 4 minus 2, I get s. So 10n divided by 2s. And the answer is 5, and s minus 1. This is same here. So next one is number 2. For the diagram below shows the distance time graph for the journey of a bus from one town to another for a period of 14 minutes. Use the graph. Also see the question. Question A, state the duration of time in minutes during which the train is stationary. B, calculate the speed in km slash n minus 1 of the train in the first 10 minutes. C, find the distance in km traveled by the train for the last 10 minutes. So let's do it one by one. Question number A, find the duration of time when the train is stationary. Stationary means the distance doesn't move and the gradient is 0, which means the line is straight line. So it's J to K. So we can find duration J to K. You will straight away take 30 minutes out. It's slow because from here to 0 to 10 it's not stationary. So we will take 30 minus 10. So we can find J to K. So it's 30 minutes minus 10 minutes equals to 20 minutes. So answer is the duration of time is 10 minutes. So next is calculate the speed in the first 10 minutes. So you find this first 10 minutes for speed using the formula for it. So for distance is 20 minus 0. And divide by 10 minus 0. You'll see the answer. 20 minus 0 km divide by 10 minus 0 minute. So 20 km divided by 10 minute equals to 2 km slash 10 minus 1. This is a unit. And further C is find the distance you can travel by train for the last 10 minutes. So you find the distance for this last 10 minutes. So we just take 40 minus 30. So we just take 20 minus 0, which is 20 km. See that? 20 km minus 0 km equals to 20 km. So next, we have finished the distance time graph and the level speed into the speed time graph. So speed time graph, as you see, the speed time graph, there is speed. So you can differentiate with the y-axis. Is this distance time graph or speed time graph? So for the distance time graph, for the gradient is equals to speed divided by time, and also equals to the rate of change of speed with respect to time. Equals to acceleration. And for speed time graph, it will ask you to find the distance travel, which is mean by area under the graph. Let me give you one example here. So, for example, if the question asking you to find distance travel in 20 seconds, in 20 seconds, which is here, so when you find this triangle, because it's area under the graph, the line is here, so it's under. So it's a yellow color here. So for the triangle formula, it's 1 over 2 times side and time base. So it's 1 over 2 is 20 equals to 200 m. Because it's area, so the units is meter. So we must use short one is m. Next is problem. For a question, this is the diagram above shows the speed time graph of a moving object for 14 seconds. This is the graph. Question A, state the length of time in seconds that the particle moves with constant speed. Question B, rate of change of speed in the first 10 seconds. Let's start with question A. So this question asks you to state the length of time when the particle moves with constant speed. It is here, as you can see, because the speed is not moving and remaining the same. It is following constant speed. So we need to calculate the time here. So we don't straight away take 30 seconds. We take 30 seconds minus 10 seconds. 30s minus 10s equals to 20s. X is mean seconds. It's a unit for second. So E is find the rate of change of speed. This is familiar with this rule. Let's see. Rate of change of speed is equals to gradient and also equals to speed over time. So this question we need to find the speed and time and divide it together. So we find for the first 10 seconds, which is here, this corner. And for speed is 5 minus 2. And then divide by 10 minus 0. 5 minus 2. The unit for this is m slash s minus 1. And then 10 minus 0. S has to 3 divided by 10. I will say 1, and equals 0.3. M slash s minus 2. This is the area. After it divide it, because here is positive 41. And then divide it, this take out, it's become negative 1, negative 2. And then the expression C. Total distance travel of the object in 40 seconds. Distance travel. So area under the graph. Area under the graph. 85 for the whole graph. And as you can see, here's trapezium, rectangular, and a triangle. So see answer first. We to add on together, area J, area K, and area L together. So for trapezium, formula is 1/2 times 2 side, which is 2 plus 5, and then times 10. The next is rectangular. So it's 5, okay, and also we take 30. We use 30 minus 10 and times together. And triangle is 1/2, 1/0 times 5, and times 40 minus 30 is here, it's equals to 10. So it's equals to 35 n plus 100 n plus 25 n. The answer is 160 n. And next, you can also use another way, which is you can see the trapezium. If you draw a line here, this is a small square, and here is a small rectangle. So you also can, behind 2 is remaining the same. You also can use a small triangle first, or 2 times 5 minus 2, which is equals to here, and then times 10 plus 10 times 2. And then behind is still the same, so it's 50n plus 50n plus 100n plus 25n. So the answer is almost same, 160n. So next is example 2. The diagram above shows the speed diagram of a moving object for 12 seconds. Find the speed of the object at t equals to 6s. The distance traveled by the object for the first 8 seconds. So for it is finding the speed when the object is at 6 seconds. So if at 6 seconds here, go up. Here is you see is the speed is 8. So the speed of the object at t equals to 6x is 8m slash s minus 1. And so question B, distance travel. Distance travel means find the area under the graph. So the first 8 seconds, which is here. So the question is asking you to find the area under the line, which is the shape is triangle. So it's giving here's 8 and here's 10. So 1/2 times 10 times 8, 40n. So we have finished distance time graph and speed time graph and the example. Let's do some extra exercise. Exercise 1. Diagram shows a distance time graph for the journey of a car from Kuala Lumpur to Penang. This is the graph in this question. A. State the duration of time in hours. The driver stop and rest at Ipoh. B. Calculate the speed in km/h-1 of the car from Kuala Lumpur to Ipoh. You can stop the video first and do it yourself for this exercise and exercise after this, and then check the answer after you've done it. So for question A, you can state the duration of time and the unit in hour. The driver stop. Stop is means stationary, the gradient 0, and rest at Ipoh. So let's see, Ipoh is here. And for here is start rest at 2 hours and rest at 2 hours. So the answer is you take 3 minus 2 hours equals 1 hour. So the driver rest 1 hour at Ipoh. And then let's calculate the speed. So the speed is distance divided by time. So it's Kuala Lumpur to Ipoh, which is this area. We need to find the speed in this area. So it's 190 minus 0. First of all, let's write 0 here. And then 2 minus 0 and divide it together. 190 km divided by 2 hours equals to 95 km actually. So the answer is speed of the car from Kuala Lumpur to Ipoh equals to 95 km. Section 1. And next is question C. Calculate the average speed in km/h of the car for whole journey whole journey with a whole graph. And for average speed, it's also like final speed. Assuming the total distance and divide by time taken for a whole journey. So total distance obviously is 300 and time taken is 6. So I use the 300 km divided by 6 hours equals to 50 km 6 h plus 1. So the average, so the average speed of the car for a whole journey equals to 15 km per h plus 1. So that is exercise 2. Diagram shows the distance time graph of May, June, Alex in a 15 m swim race. So for OH is May's swim. For OZ1 is June's swim. For OABC is Alex's swim. Each person swims represent different color, so you can easily see it. So let's see the question. A. Who won the swim race? B. During the swim race, June was injured and she stopped swimming. State June's distance in m from the finishing line. From the finishing line when she stopped swimming. So if who won the swim race, let's see there's 2 people who reach 15 m, and you see tries the time shorter. So May use 70 seconds. Flash use 115 seconds. So already, so obviously, May won the swim race because he used 70 seconds for 50 m. So let's need to find the distance from the finishing line when she stopped swimming. So she stopped swimming here, and we find this distance. Distance is stopped swimming line. It is 30 m, and the distance is 50. So we just get the finishing line minus 30. 50 minus 30 m equals to 20 m. And C, calculate the average speed in m sub s minus 1 of x. So we find average speed for x1. X is red line. So the total distance is 50 m and time taken is 150. So 50 m divided by 150 again equals to 1 over 3 m sub s plus 1. So the average speed of s equals to 1 over 3 m sub s plus 1. Exercise 3. The diagram above shows the speed time graph of a moving particle for 50 seconds. 50 seconds, this is a graph. Question A. The length of the speed indicates that the particle moves with uniform speed. B. The distance traveled by the particle when it moves with constant speed. So let's read question A. Find the length of time when the particle moves with uniform speed. Uniform speed is mean constant speed. So this is 0 when constant speed is 5 here. And then in find length of time. Length of time is 0. So we need to find 6 until 12. What is the time? So it's 12 minus 6. Oh, that's 12 seconds minus 6 seconds equals to 6 seconds. And the distance traveled is area under the graph. For constant speed equals to uniform speed is 4 by same. So we need to find, imagine here got line to line. So this is a rectangular. So we need to find the area rectangular. So here is 5 and here is 6. We just find it. So 6 times 5 equals to 30. And next I can see the distance traveled by the particle when the rate of the speed change is positive only. So for here is negative. Here radius 0. Our rate of the speed is also negative. 0. Here is negative. Here is positive. So this is travel here, area under over here. This is a trapezium shape. So 1 over 2 times here 5 and here is 50. So 1 over 2 times 5 plus 50 times 50 minus 12. Also related 50. We define here, which is 3, 50 minus 12 equal to 3. So the answer is 30 and next exercise 4. Diagram shows the speed time graph for the movement of a particle for a period of t seconds. Question A. State the uniform speed in ns minus 1 of the particle. B. Calculate the rate of change of speed in ns minus 2 of the particle in the first 6 seconds. So question A. Uniform speed equals to constant speed. So constant speed is here. The speed is not moving for a while. So the answer is 6m s minus 1. Remember to write the unit together. Next, calculate the rate of change of speed for the first 6 seconds, which is here. So rate of change of speed is also speed over time. So the speed 6 divided by the time 1, 6. 6 divided by 6 equals to 1 mz s minus 2. And the question C, calculate the value of t. If the distance traveled in the first 6 seconds is half of the distance traveled from 10 second to the t second. So it's been distance traveled here, the area here is equals to 1 over 2 of the area here. So here's the answer as Taylor showed. So here's triangle trapezium. Triangle 1 over 2 times 6 times 6. And equals to 1 over 2 is, don't forget, there's 2 1 over 2. 1 over 2 is because of, we need to find the t. And this area is equals to 1 over 2 of this area. So, and for formula of trapezium is 1 over 2 times 6 plus 14 times, here we gotta find it because of 2, so e minus 10. And that's 18 equals to 1 over 2, 10 minus 10 times t minus 1, 10. So that's t equals to 5, t minus 10, the 1 over 2 times inside 2 plus 10, so equals to 5. And then that's 5 times inside 2 5, t, and then negative 15. And then move to the front, 18 plus. And then move to 5, 18 plus 15 equals to 5t. So I go up is 68 equals to 5t. 68 divided by 5 equals to t. T equals to 13. That's all. Thank you so much. Hope you like it.